The year 2020 has been hallmarked by the novel COVID-19 disease. It has sparked profound innovation throughout the scientific and healthcare world in order to provide a sense of normalcy during the time of a pandemic. One area that has seen a lot of innovation is college testing methods. Yale first developed Saliva Direct, a saliva enzyme test that can determine if an individual is positive or negative for COVID-19. Rutgers created a very similar style of test. Georgia Tech, however, created a saliva test that utilizes mechanical disruption process. This process uses a mechanical disruption machine. This machine can hold up to 48 samples and is currently loaded manually one by one. The lab can accept up to 2,500 tests per day, so this makes this step a bottleneck. Currently, Georgia Tech has had about 1,400 positive COVID-19 cases, and testing is still as important as ever. Therefore, Georgia Tech laboratories need more efficient, cheap, and durable testing components to improve speed and efficiency of COVID-19 surveillance and diagnostic saliva sample processing.
In order to address this bottleneck, we wanted to create something that could help the lab personnel quickly load the mechanical disruptor machine. The current method of loading the test tubes into the machine takes a minute and a half, and the lab is accepting 2,500 test tubes in one day, which means that the mechanical disruption machine would be loaded up to 52 times in one day. This means that the lab personnel spend almost an hour and a half each day just loading the machines. Our goal was to cut down this time and streamline the lab's process. We achieved this through the creation of a ring loader. This ring loader can collect 48 test tubes at one time and orient them properly into the machine. This meets the essential objective of loading the machine easily and the critical objective of loading all 48 test tubes at once. This will allow for more tests to be processed in a day. This design is unique to the machine that it loads. There are 3 of these machines in the lab currently, and with 3 ring loaders, we could cut down their time spent on this part of the process by almost 80%.
Before being loaded into the mechanical disruptor, individual test tubes are mixed together in a bin to randomize which samples are being pulled together. These test tubes are randomly oriented, which makes the task of loading 48 test tubes into the mechanical disruptor take up to a minute and a half. Some of our original ideas addressing this concept problem included creating a chute to more easily load tubes and creating a circular rack to prearrange the tubes in the correct orientation. Eventually, we settled on a magnetic ring loader that would allow the test tubes to be easily pre-oriented into the positions that would fit the mechanical disruptor machine. Our first prototype for this design concept simply consisted of a foam board and a 6mm neodymium magnet. We used a test tube with the same magnet attached at the lid. This prototype showed us that the magnetic strength used was strong enough to easily pick up a test tube, but weak enough that the tube could easily slide off the loader once securely in the mechanical disruptor rack. From this prototype, we learned that the magnet on the loader and the test tube should be the same size, so that the tube's location is controlled. We also learned that the magnet size should ideally match the tube lid size so that the loader can more easily pick up tubes that are laying on their side. Our second iteration was shaped as a ring to account for the shape of the mechanical disruptor rack. While this prototype functioned similarly to the first, we realized that fingers would get in the way of some of the magnets during the loading process. Therefore, our third iteration includes the addition of handles to ensure that no magnets are obstructed. This prototype creates a more intuitive design for the users to interact with and meets the critical design inputs of correctly orienting the test tube and the essential input of the appropriate magnet strength.
We were inspired by the design of a speed loader that is commonly used with revolvers, coupling that with magnetic ability in order to create a ring loader that would be able to attract and pick up the test tubes in a ring orientation positioned upright to easily load into the ring shape of the mechanical disruptor machine. This is our design concept, showing a ring with 2 handles and 48 magnets spaced around the ring to attract the test tubes. The magnets are arranged in 2 circular patterns with an inner and outer circle to maximize the amount of test tubes that can be tested at once. The ring itself has a 7 3/8 inch diameter. This ring could be made out of any inexpensive material. It's shown currently in acrylic with 10mm neodymium magnets. Here you can see our ring being used to pick up multiple test tubes at the same time, thereby increasing the efficiency of this step in the COVID-19 testing process.
Based on feedback from the lab personnel that worked directly with these machines, they noted that their time could be cut drastically even if the ring loader wasn't perfect. The most helpful thing to them would be to have all of the test tubes oriented properly to prepare for loading. We conducted a time test on our device in order to determine if it meets the design input of saving time. With the lab's current ability to take in 2,500 test tubes a day, we determined that the lab currently spends an hour and a half per day on the loading step, and that this device could cut their time down to about 20 minutes per day.
Moving into the business case, the global COVID-19 diagnostics market is valued at $19.8 billion in 2020, and it is expected to grow at a compound annual growth rate of 3.1% from 2021 to 2027. With significant increases in COVID-19 cases, especially now, it is more important than ever that users receive their diagnostic results back as quickly as possible. Our device will reduce the amount of time required to process samples through a mechanical disruption machine by a factor of 48, thereby addressing a major bottleneck in the existing diagnostic process, and in effect, we're returning results back to users quicker. This device is extremely cost-effective for its value as it is made out of cheap materials such as plastic and magnets, and thus this device provides value by reducing the diagnostic processing time while also being affordable for users. Our next logical step is to form a company and appoint each team member official roles. We will then begin filing patents with manufacturers and diagnostic laboratories to begin personalizing their magnetic loaders.
The ring loader is more of an assisting, time-saving device within the process, so it would most likely be classified as a Class 1 medical device for the FDA. Georgia Tech's COVID-19 testing process is currently awaiting final approval from the FDA, so to be part of that process, we would need to be written into the protocol. Hopefully one day we'll be able to sell our ring loader with the mechanical disruption machine itself.